Hello everyone. Today we're going to talk about completing the square. Right, so why complete a square? We have some quadratic equation, f of x, and we know that there are some roots associated with this quadratic. They may be here and here or somewhere else on the graph. They could be up here. In case they'd be imaginary, there might just be one, but we want to figure out what's going on here. So we're going to complete the square. Let's make sure that this is set up nicely. Okay, so when we do this, the first thing we need to do is make sure that a is 1. So right now, a is 1 over 4. This is not going to work for completing the square. So we can use algebra like we always do. Let's see, this is the penguin here. Keep that in mind. So what do we do here? We want to divide. Both sides by 1/4. So before we do that, it might be helpful to move this -7 over. So we could have 1 over 4 x squared plus 2x, that's just going to equal 7. And we remember the first step of completing the square was to move this over so that we're just dealing with our x's. So now we can divide both sides by 1 over 4. But the equivalent to doing that is just to multiply both sides by 4, which is a little bit easier. So, right? And really we're just doing this to make this a 1. So if we multiply this, we get, it's really 4 over 1, right? So we just get 1, we have x squared plus, and then 4 times 2 is 8x equals 28. Yeah, so the next step is then, over here, the penguin side work area, we're going to figure out what 1/2 of b, which is 8, squared equals. So if we have 8 over 2 squared, that equals 4 squared equals 16. So we're gonna add this to both sides of the equation. So we'll have x squared plus 8x plus 16 equals 28 plus 16. The thing that you're left with on this side, you can then unfoil. Everything here is positive, so we know that these are going to be positive. We need these to make our x squared. We need to make 16, so 4 times 4 would do that pretty well. We can also see that they're going to add, 4 and 4 is going to add up to 8x nicely. So we'll have our 4's. I happen to know that this equals 44. And here then we observe that we have the same thing twice. You'll always have this when you complete the square. So we're going to rewrite it like so. And then from here, we can just do what we always do. We take the square root of both sides, either plus or minus there. So that square goes away, and we end up with plus or minus the square root of 44. Last thing to do is to move that 4 over. So we have x equals -4 plus or minus 44. We can simplify this bit. We'll do it up here in the side work area. 44 equals the square root of 4 times 11. And this is just 2. So we have 2 square root of 11. So we've simplified that. So then we're going to end up with x equals -4. So there's a plus case, plus 2 square root of 11. Or x equals -4 minus case minus 2 square root of 11. And that's how we use completion of the square to figure out what these roots are. If I ask which one of these is which, I think it should be pretty clear. We don't know exactly where they are. I mean, you might figure out in your head, well, the square root of 3, which is a little bit less than this, or square root of 9, which is a little less than this, is 3. So this is somewhere between 3 and 4. So let's just say it's 3. 2 times 3 is 6. Negative 4 plus 6 is negative 2. So this one might be somewhere around here. And then we would have a 2 times 6. So we'd have minus 6 over here, right? So this might look like 6. This might is approximately 6, and this is approximately 6. But in this case, we're subtracting more, so it may actually be that this looks more like this, and we're somewhere on this side of the graph. So you want to get used to, roughly approximating what these square roots are. It's between 9 and 16, so it's somewhere, the square root's somewhere between 3 and 4. So roughly saying the lower bound is 6 here and here is fine, and then of course, negative 4 plus 6 is just going to be negative 2, and this will be somewhere around negative 10. Right, and so that's all we're really doing. It's not so. This isn't such a monster, but these are our roots, right? This is what we're actually looking for. These are the guys. All right, hope that helps. Take care.